So for this video, we're going to work on some reflection review. So with this graph, we're doing a hexagon, and we're going to reflect it for this time over x equals negative 3. So x equals negative 3, I'm going to do a line with a different color. This I'm using a highlighter. And then this right here is x equals 3, and that's what I'm reflecting over. So what I'm going to do, I'm going to look at it. I'm going to do each point at a time. So with this point right here, I'm going to count the amount of squares it is away from x equals negative 3. So that's 1, 2, and 3. Alright, so from right here, the same amount of points it is away from this line this way is the same it needs to be on this side. So that was just 3. 1, 2, 3. This one is going to be 1, 2, 3. I'm going to put a dot there. I'm going to do it for the next one too. Down here we're going to start at this point. We're going to go 1, 2, 3, 4, 5. So this is 5 units away from x equals negative 3. So if it's 5 units this way, it needs to be 5 units the other way. 1, 2, 3, 4, 5. That point right there. Now I'm going to continue on, and I'm going to count each square. I'm not going to count it out loud. So if you know how to finish it up, go ahead and finish it. But I'm still going to go points at a time, and then I will draw the new figure. Okay, so I have all the points reflected across x equals negative 3, and now I'm just going to connect the dots. So, connect that one, connect this horizontal line. I'm going to use the straight edge to connect this one, and then this one. And the last 2 points to be connected. And that is the hexagon reflected over x equals negative 3. Alright? So now we're going to do one more reflection. This one's going to be a little trickier. This reflection, we're going to do the same hexagon, but we're going to reflect it over y equals negative x. Now, you did y equals x in class. So, like I did in the last one, I'm going to draw the line that I'm reflecting across. Alright? Again, I'm going to do it in a highlighter, just to be a different color. And this line has a slope of 1, so it's a little easier to draw that line rather than one with a slope not 1. Alright, that is your y equals negative x. Now, with y equals x, your coordinates, just your y became your x and your x became your y. But since you're over negative x, both of these, it's the same, y equals x. But since this is a negative, these both change signs. Like that. So this point right here is at 2, negative 2. So right now, 2, negative 2. In order to change it, we have to flip it the other way. So it's going to be negative 2, 2, but then you also have to change its signs. So then that's going to be 2, negative 2. So it's pretty much staying at the same. That might not have been a good example. So we'll go ahead and mark that point, and then we'll do one other point to show how it changes. Let's do this point over here. This point is currently at 7, 1. Alright? So I'm going to write it right here. Now, to reflect it over y equals x, we just change x is now y and y is now x. So it's 1 over 1, 7. Now since this y equals negative x, we have to change the signs. So now we have -1, -7. And so I'm going to do that. I'm going to mark that. Here's my -1. Go down 7. 1, 2, 3, 4, 5, 6, 7. So that is that corresponding point right there. Alright? So now I'll do one more example of changing the coordinates. So this point right here is at 5, -2. Okay? So that's where we start. So now we're going to swap them. So y is now x and x is now y. Since it's y equals -x again, we change the signs. So 2, -5. Alright. So we're going to go to 2 and we're going to go down 5. 1, 2, 3, 4, 5. Okay? And I'll continue doing that with the next ones, and I will show you, then we'll see if you got it the same way I did. Alright? Alright, those are the other points that I got. I can kind of see the hexagon without having to connect it, but now we're going to connect the dots and see what we get. And that is the hexagon reflected over y equals -x. Now don't forget that if it's y equals -x, it's not just flipping x and y. You also have to change the signs, or else it's going to be a little crazy. Alright? So now this is the end of the video, but I'm also going to show you the problem of the week. So if you do not want to participate in it, you don't have to continue watching. But this is going to be the problem of the week. This is what you are going to start out with. Alright, this is the picture that was given, and this is also what was given in the problem. And you are trying to find out if triangle TIE is equilateral, this inside triangle. Alright, this problem is going to be due on Monday, which is March 4th. You have your name, class period, and the time you turned it in. Alright, I will give you a hint, because this may or may not be a hint for those who want to do it some way and some that do another way. But like we did in the video before this with the proof, the first step was to separate the triangles. This may help you, this may not, but this is what it would look like with separated triangles. I separated all triangles possible. Alright, so that may help you, that may not help you. And this end is E up here. Alright, but this is what you start out with. So go ahead with that and have some fun. Thanks.